so we just know how to do this right. On top of that, our customers' clusters are, as we increase the technology that we have, our customers' clusters are more and more elastic. So there isn't this, oh, well, there's on-prem versus, or Azure or AWS. We're sitting right in the middle saying, look, we are the Hadoop cloud. We're not Hadoop on top of AWS. We're not Hadoop on top of VMs. We are Hadoop on top of tuned infrastructure. And at least the studies that we do with our customers just show that not only does infrastructure that has been built and tuned for Hadoop really beat the infrastructure as a service providers, but also the time to get a good result is a lot faster on our infrastructure. So yeah, you can, so out of the gate, we tend to get factors of 2 to 10 faster than anything running on AWS. And yeah, you can spend, our performance guy comes from Netflix, so he knows Amazon inside and out. And yeah, if one of the performance folks who knows Amazon inside and out gets there and tunes and tunes and tunes and tunes, he can kind of get within maybe spinning distance of our clusters, but that's after weeks and weeks and weeks of tuning. So our experience is just totally different, and we just believe that a purpose-built cloud for big data is just, we just see that winning in terms of both time to value and total cost of ownership.
For what it's worth, I'm going to take the middle road in this one because S3 is great and as these guys said, like we've actually seen pretty good results. It has very good network connectivity. So does Azure's blob storage. What we find is that these guys have built clouds which have very good bisectional bandwidth across to these storage systems. So we've not had that challenge in that sense. I agree with like a lot of what Ashish was saying is definitely hit us as well in terms of like maximizing performance. You often need to do things like even if I don't need the compute to actually process the data, I need more instances to actually get the appropriate bandwidth from S3, which sometimes increases the cost in ways that you would not expect. But you can still get very good results at very good price-effective manner. Having said that, not all workloads will work off of S3 in my opinion. There are certain workloads, like you take HBase or one of these NoSQL databases for instance. I don't think they're going to run off of S3 anytime soon because their latency requirements are very different from that of a data processing pipeline, for example. So you have to be a little cautious in terms of the types of applications you're running because even these clouds provide local instance storage, which actually give you pretty good performance. Yeah. So in certain situations, whether it's HBase or whether it's some other system that is latency sensitive, you may want to use a local instance storage on these cases, in which case you're paying a virtual machine tax maybe, but it's really, I came from VMware, virtual machine tax is not that big a deal. Okay, so I think it's not the end of the world from that perspective. And when the situation is appropriate, like a good data processing pipeline, S3 is often, or Azure data storage is actually perfectly fine mechanism. You may need to spin up a few more instances than you would in a persistent cluster, but the advantage is you get to turn this thing off and recoup some of your costs.
Right.
So,
right. And that's why even for HBase, right? If you have this, if you treat HDFS as a cache, then you can bridge those gaps as well. So however, the elasticity benefits that you get, and even the cost benefits, like if you store data in the cloud on S3 versus running a long-running cluster and storing the cloud, data there, it's an order of magnitude more expensive than just doing that. So that helps. So I think there are architectures that can help you span the stuff, and as Jay was saying, scalability doesn't become an issue. I have not seen that becoming an issue as such.
Yeah, I will say something just so that we're not. We all have an interest to talk about how awesome the cloud is and these services are in the cloud. But one thing we've struggled with is Hadoop is built by people mostly or it has been built by people mostly who were working on-prem. They were working with clusters that were on-premise, and the way we often talk about that, at least in my team, is Hadoop assumes a dumb data center. Like it assumes commodity hardware that isn't smart about what it's doing. And if you take a system that assumes that and you put it in a cloud that actually assumes that it's smart, or the cloud's self-healing and it detects, it's auto-patching and things like that, the two things can actually outsmart each other. and you run into problems with Hadoop and the cloud, like recycling when it's patching and things like that. And that's an area where we've had to invest, frankly, a fair amount to try and make it so that they coordinate well. And that's something where we actually are investing in Hadoop at the resource management level and basic parts of the operating system, if you think of Hadoop as a distributed data operating system, so that we can run that very well in the cloud. And I don't actually disagree. You can absolutely tune. I love your answer about you can tune Hadoop to run very well in the cloud. I hope that's where we can make where we can take Hadoop over the next several years is better optimized for cloud execution than anything else.
All right, I think we have, I see a question in the back, a question here, and a question over there. I think this guy over here also has a
Okay.
little one.
Thanks. Couple of questions. When you think about Hadoop as a service, two things come to mind. One is the clients who actually want to use that as service. What are they most feared about? What are the apprehensions? Is it service level agreements? And second, how do you actually provide that as a service? Do you actually have a set of APIs that use, say, Hive, or we have a set of APIs that actually use, say, here's a whole bunch of data I want to store in HDFS. How do you go about doing that?
So for us, we provide API level access in case you want to do any of your own tools and want to hook them up. So we have a REST-based API, we have a Java SDK or Python SDK, and you can do that. We also provide you higher level tools which can enable your analysts to fire off queries, SQL queries, or MapReduce jobs, or pick queries, or even tools which can enable your analysts to build data forms for people who don't know how to write SQL. So they can completely encode that logic in a simple data form, which is again running on this infrastructure. And the beauty is your business ops user is just entering a data form, getting back a data feed, and all that is being processed all the way down into Hadoop. On-demand clusters come up and go away, and there is no operations needed for all this, or very little operations. I won't say there's no operations. There's some operations, but very little operations. The operational footprint goes down very significantly. Just to give an example, Pinterest supports its 400 odd users that are on our system, with 1.5 people managing that thing. And before they were using us, they had only 30 odd people that could use the technology through APIs and things like that. So I think you have to think multiple interfaces. You don't have to think one particular interface. You have to think multiple interfaces, and then it becomes a true service that can get embedded in multiple places, whether a developer is writing some tool that they can come through an API, or an analyst is going directly to the interface, or a Tableau user can come through an ODBC driver and hit this. Though there are performance implications there, and some things have to be improved there, but all those it's a multiple interface access as far as we are concerned.
One of the interesting differences from sort of traditional Hadoop applications, as we call them, and when I refer to applications here, I'm talking about like data pipelines usually, is that a traditional application sort of assumed an environment is going to run in. In this world, like your scheduler often is creating the environment it's going to run in as part of that flow. So the APIs are very DevOps oriented from that perspective, where you're really saying, hey, my execution environment itself is part of my the construction of the execution environment is part of my application flow, so your APIs are to provide that level of abstraction in an easy to consume manner. But I mean, beyond that, of course, there's clearly the standard ways of like how do you interact with your ODBC or JDBC drivers, and like interactive like UIs, or if various vendors have various choices for that. But I think the big fundamental shift has really been around that fact that your application has a slightly different concept of actually provisioning its own execution environment, which is a bit different from before.
So I'm going to take a slightly different angle on this, which is around the SLAs. And so we have an SLA that is 3 nines, availability of the cluster at all times. And then we go beyond that and we monitor the apps that run, the Hadoop apps that run. So we have runners that check the Hive stack every few seconds to make sure that, on all the clusters, to make sure that they're healthy. And if they ever fail, then people on my team get woken up, or whenever, whatever they're in the middle of, they get interrupted, and we work until it's fixed. And so that has us, that's actually led to some dynamics in the team of, we for a long time we wouldn't let you install just anything on the cluster because you'd be able to run as admin and then you could format the drives and then we get woken up in the middle of the night because you formatted your drives and we didn't want to do that. So it was this struggle of, well, people want to put the latest and greatest components on, but we haven't hardened the component and we can't, so how do we guarantee the SLA? And we finally decided, because we kept getting the requests, that we're going to just open it up. And so starting next month, you can run as admin on our clusters and put whatever you want on there. And we're kind of hoping that the way that works out is that people will just be, you know, good about how they do it. And if they bring down their system, we'll still do everything we can to help them and to heal their cluster. It might get to a point where we say, look, you formatted your drives, so you got to undo that. Now, the benefit of the cloud model, though, is that you can blow a cluster away and bring it right back, and it's not that big of a deal if you misconfigured it, because your data is persisted independent of that. But that's kind of where we've landed on it. It is a challenge, I think, for us.
We take a slightly different approach to SLAs. We essentially say that we'll have 100% uptime, and then we provide credits if there are any unplanned outages. And it really shows how early days we are, because it's an interesting conversation with our customers where our customers purchase a monthly plan for a certain amount of compute. And then over time, we're trying to build this thing that we call infinite compute, which will essentially let a customer use their whole monthly plan if they want in the space of an hour, right? So now we get to have that conversation about, well, if that particular hour is when we had an outage, what's the remediation around that? So it's a sign of how early we are in the market, and it's just exciting to be getting into these conversations with our customers in a very dynamic way to understand, okay, how does the pricing sort out? How is that going to work for everybody? How do the SLAs sort out, and how do these interact with each other?
For what it's worth, the SLA management thing, the cloud adds another dimension, but I don't even think it's the biggest dimension with respect to SLA management at Hadoop. There are so many other challenges with respect to even just the core resource management tools available that have to be addressed in order to get like really guaranteed performance via jobs that also have to be dealt with. This is not the only part of the story.
Yeah,
Here.
but the complexity is enormous. That's
Yeah.
what I was asking. You know, in the
Yeah.
olden days when you were running as hosting as a service, it was very easy. You had network performance, you had disk performance. Now you have this exponential components running in each and every job requires a different level of
Exactly.
service agreement.
Sorry.
We have a question, right there.
Yeah, hi. I have a question, I have a comment and a question. So the comment is about the size for Hadoop, you know, the typically said for smaller data sets is not big, good. But one of the 1 minute terasort benchmark was run by one of your competitors, like on a Google Compute platform with 1,000 VMs so in the cloud. So probably looks like it's not even just for 1 terasort. Seems to be okay doing that. And the question is like, in general, like what are the typical average size of your customers? And I know that, you know, you have different, even though you say it's Hadoop as a service, but you know, like you are giving Hadoop on more or less like a private cloud, I guess, on scale, and Kubol is like a more or less middleware as a service, right? So what is the typical, I don't know what metrics you use, but what is the typical
So Kubol is more, it's still Hadoop as a service, it's not middleware as a service, but it's Hadoop as a service provided through clouds like AWS and Google. So we, you know, as opposed to Autoscale, we are not standing up our own cloud. We are using the existing clouds and bringing those benefits to Hadoop. That's what we are doing. Average size of customers, there's a lot of variance. The biggest ones are running, as I said, 1,500 to 2,000 node clusters. The sweet spot, I think, happens around 50 or 50 odd nodes. I think that is a sweet spot where you will see the median. There's average and there's median. So median is around, I would say, 50 to 100 nodes. That is where you see the sweet spot of the clients. And then there are outliers. There are the outliers like 1,000 node clusters. And then there are outliers in the other direction who are running like 2 node clusters, and that's where I really question, why, what are you? And typically, people who understand what they're doing, they're typically using it for test dev and trying to get But there are sometimes we get folks who are, you know, very clueless about.
Is it same with all scale to 50 or 40?
Yeah, that's not a bad pin to put in the wall right now. And, you know, I said tens of terabytes to small numbers of petabytes for the companies over the last couple of years that have been coming onto Hadoop as a service. I think that we're starting to see a sea change where, and then Jay mentioned, yeah, you can start with a relatively small data set, but if you're doing something incredibly complex with it, then you know, you actually need some serious metal to be able to handle that. So, yeah, I guess my bias is I'm much more interested in the business use cases these days and what it takes to address them. And we too run into the potential customer whose data could fit on a USB stick, and we kind of have to say, you know, where are we going with this, right?
We have time for one or two more questions, I think.
You did the microphone.
That's a question on the higher level, maybe to Elizabeth. The question is from Lance. You mentioned the data operating system, and I hear it more and more. How do you define it? What do you mean under it?
Did everyone hear the question?
So I'll repeat the question here just so to make sure. I think the question was, if you think, what do you mean by when you say Hadoop as a data operating system?
I didn't say Hadoop.
Oh, sorry.
Because I'm not sure that it would be Hadoop.
Okay, so
Maybe.
yeah, I think then the question was, I said data operating system. What do I mean by that?
Yes.
Yeah. So what I mean by that is it. And I think one of these guys made a comment earlier where they said Hadoop is not MapReduce. And so often I think people think of Hadoop as Hadoop equals MapReduce. Probably not people in this room, but my customers will often think that. And so I will talk to them about how Hadoop has evolved. And I think of just like any other operating system that has resource management, it has a file system, it has the ability to execute applications. You might have you might have a word processor, you might have a photo editing application. Those are all different kinds of apps that run on the same operating system with the same hardware and use that together. I think that, we'll just say the big data platform is evolving to be like that. Personally, I think Yarn is kind of the closest thing that's heading that direction, but whatever one wins, is fine with me. I just think there should be some common way to manage resources and then run workloads on top of those resources.
I don't know if I need the mic. Hi. So earlier, no one said this explicitly, but it was kind of hinted at that if you have big data, you should use Hadoop, and if you have small or medium-sized data and you want it fast, you should use some other system. So how long will it be, or what will it take until we have one system that handles both of these cases?
Go ahead, ask the easy questions.
Yeah.
Good. Your turn?
We're all waiting
Okay.
to see who. Go ahead.
I hope there's one. I think there should not be one system. There should be a few systems. I think that is the. If you have one system, then you're basically in a monopolistic place. So the good thing around Hadoop is certainly, if you look at the technologies such as Spark and those types of technologies, they are trying to. So Hadoop came from the high end, right? So it said, okay, the first application on Hadoop was search index, building search indexes, very large set of data. Then, when we did Hive, then we said, okay, now you can have SQL use cases on Hadoop. Then after SQL use cases, people said, okay, this thing is, slow or whatever, right? So maybe we need another engine. So, the Impalas and the drills and the Prestos of the world emerged there. And then, the Spark guy said, okay, we'll do something in memory. So as you see, the progression is all towards, how while one progression was large sets of data and batch processing, the other set of progression when you get to in-memory is like smaller sets of data and faster latencies and things like that. So in terms of the ecosystem projects that are emerging, there is definitely a promise that it won't be a single system, but it might be an umbrella of under the Hadoop umbrella there might be multiple systems which will solve that that dream. There's still a lot of work to be done in order to get there though. It's hard to say when.
I'm not even sure there
I
is going to
wish-
be such a point in time, frankly speaking. That's my opinion, but I'm a little pessimistic, I guess.
It's hard to say, yeah. I mean, it might not converge, I don't know.
There's kind of a continuum of computing that we do, right? I mean, the things we carry in our pockets have how many orders of magnitude more compute and memory than the computers that took people to the moon, right? And well, that's what's amazing about this industry. We're still riding the crazy train of Moore's law, and so there's going to continue to be incredible diversity of sizes and shapes of data and compute needs and applications. And I don't know, I feel truly blessed to have been riding this curve for the last however many years and
2 years.
and yeah, 2 or 3 years, and it's just so exciting to see where this is all going, especially when you combine that with the fact that we have real problems with 7 billion people and growing on the planet, and yeah, the technology is always a two-edged sword, but to try to look for those kinds of applications where computing in the small can bring us together as human beings, and computing in the large can figure out how to deal with climate change or other resource issues. I mean, one system to rule them all isn't really the goal, is it?
David, I think that's a fantastic way to end on, because we're running out of time. But I'll just wrap up to say, I thank you so much for having me, and it was a really great panel. I learned a ton. I hope everyone did. And also, I did not bring any cards, but if you want to get in touch with me, I'm always looking for story ideas, and it's just my first name dot my last name at wsj.com.
Thank you, Elizabeth. All the panelists, David, Ashish, Jay, especially Lance. Lance flew in from Redmond for this, and we hope to see you again, because we do this every week. And appreciate the great questions from the audience, and maybe they have a few more minutes after the talk, and you can chat with them. Thank you, guys. And hold on 1 second.
Thank you. For a favor, if you could speak up after yourself, just the place, and that would be really nice. Thank you.
That was great.
How's it going?
Did you like those panels? How was it? Good. Do you go often to the night? Maybe as a become a teenager, it's going on. They're actually confusing the market. Especially for this.
mean, I think I
So I hope that subsides down and we get to the real use cases.
but I do have.
That is great to see.
Not uncommon. People who
Hi.
Hi Dan, how are you? Yeah, you are on.
What do you guys have for time series? They'll usually get to security.
Yeah, there are many companies like that.
I know, normally you got a lot of no, no, who is deciding that actually? Honestly.
I thought Sandeep usually yeah, Sandeep usually calls before Tom always just calls. I always show up like
3 years back I used to hear this.
they call and I come. That's pretty much it.
I thought you were really
I still love it. I care a lot. I care a lot. Preaching kind of just tell it like it is, man. Only they can give me a serious talk about it.
We also have signed up. So Black Systems is actually collecting data from a lot of the platforms.
So,
So their objective is not